Well, you know, magician tricks may not always are what they seem to be, but Matt Sellen is here to show us a little bit of physics magic. What have you got for us today?
Okay, well, you know, I've actually, you know, it's an excuse to go to the magic store and get some tricks, okay? And I realized when I did that last time that a lot of this is physics, but a lot of it is illusion too. So ask me if I have a straw. Do you have a straw? No. Oh, but wait, maybe I do have a straw. Let me have a look in my bag. Oh, here's a straw. Oh my.
Oh my gosh. It's going up through our rafters.
Right. So this straw, right, came out of this little teeny bag. Now, that's just an illusion. Right. Okay? What it is just this long piece of plastic that's kind of rolled up. And so you can do little silly stuff like that, but there's other tricks you can do which actually have physics behind them. So let me show you a different one. Okay. Okay? Let's see if I can do this here.
No, I haven't seen these yet, so.
Right. Okay, so the wand is going to magically appear out of my hand. Ooh. Okay, so you see that? Oh my gosh. So the wand kind of came flying out, and at the same time there was this little flash which was just a cheesy add-on, which had nothing to do with the wand. Right, it was kind of hot. So at the same time as I blew up a little flammable thing, which is always kind of dangerous for the eyebrows, there was actual physics going on, which was this thing. And so this is a magic wand. And it's kind of neat. This is the big spring. Yeah. And it's all kind of coiled up and it's inside my hand. And it works on a couple of principles, I realize. There's energy conservation and stored energy. Okay. So this thing, you kind of roll it up, and it is a big old spring. Okay. Wow. And it stores up energy in the same sense that a rubber band does. Okay. So if you stretch a rubber band and you let it go. Right. Not at dawn. That's right. The thing starts to move. So right now this is a coil-up spring, and it has energy, and it's ready to do something with that energy. It wants to release it, make something move. And the interesting thing is when I hold it in my hand like this and I let it go, as much of this thing goes one way as the other. So let me just do this again. If you can sort of zoom back a little bit, and I'm just going to let go of this thing with my hand. Okay, do you see how it goes up both sides? Right. And you can feel it. This thing is sort of a solid steel thing. It is. And the reason this works this way has to do with Newton's second law, which is something that I'm teaching today when I go back to class at 8:30. Okay. Okay. And so I'm all geared up to do this. I may even do this for my class, and which also translates into something called momentum conservation. And I brought some skateboards, which I'm going to use when we come back, you know, at 7:25 or whatever it is. And I'm hoping I can get both you and Jennifer to get on the skateboards and do a little demo for everybody. Stronger. Yeah. Exactly right. Because and basically just the long and the short of it is that unless you have external forces acting on something, the center of the object isn't going to move. Okay. And so this thing has its center right about it, and it's, well, when it's all coiled up together like this, it's easy to see where the center of it is. It's sort of in my hand. Right. It's right here. And when I kind of let it go, the center of it is still right there. Harry Potter fans everywhere are going to want one of these. We'll check back with you in a little bit. Exactly, and you get to see you on a skateboard. Yes, okay. Okay. That's, if you've got any questions also for our wise guy, you can email us at the station. It is 6:53, excuse me now, so we're going to check in with Robert Rees, who's standing by outside. Good morning, Robert.
Good morning, Ann. Good morning, everybody.